Alright, in the last video we talked about the properties of inverse hyperbolic functions, which was the third learning objective. Now we're going to talk about how we can differentiate and integrate functions involving inverse hyperbolic functions. Let's get started. Alright, here's the formula card for the derivatives and integration. So let's stare at the first 6 formulas here because these are the ones taking care of the derivatives of inverse hyperbolic functions directly. You can compare those to the derivatives of inverse trig functions and see what the differences are for your own reference. But for the time being, let's check what we have here. So if you have an inverse hyperbolic sine of u, the derivative of that is u prime divided by radical u squared plus 1. This is again different from the derivative of the arc sine or inverse sine function because you would have 1 minus u squared instead of u squared plus 1 in that version. So again, please compare side by side and try to see the differences. And if you look at the last 3 integrals here, so if you have any type of integral, you have the difference of squares of this form. And remember that these are slightly different from the trig versions because over there, the roles of a and u are sort of like switched. So for example here, you have u squared plus or minus x squared. Over there, it's a squared plus or minus u squared. So if you see sort of like this distinction, so then you would know exactly what formula you're going to need to find ni derivatives of these functions. And same thing here, as you see that there's a similar version of that for the inverse trig functions. In fact, if this was a plus instead, so you have du over a squared plus u squared, and that is in fact arctan type integration, but in this case it's not because it's in terms of inverse hyperbolic functions, and as you see that, remember inverse hyperbolic functions are written in terms of logarithmic functions, so there you go, we have a logarithmic function as well. And then this is very similar to the arcsecant type integration, but again the role of a and u are sort of like switched, and in this case instead of arcsecant function we have a logarithmic function. Okay, as I said, please go ahead and review all of these formulas and compare them side by side to the formulas for the inverse trig functions to have a good grip of the differences between these 2 sets of formulas. All right, let's have a quick 2 examples here. We have inverse hyperbolic sine of 2x, and let's call this part u, and let's check the formula for that. So that this formula is the one that we're going to use here. So it's u prime divided by radical u squared plus 1. Well, what is u prime here? Well, u prime is 2, as you see, the derivative of 2x. And the bottom is radical u squared plus 1, which is 2x quantity squared plus 1. Okay, and that's it. And that you can simplify it further by expanding the bottom. 4x squared plus 1 could be the final form of that. And the next example is the derivative of inverse hyperbolic tangent of x cubed. So let's call this to be u, and let's check the formula for that. And I think we're going to use this formula now. It's u prime divided by 1 minus u squared. And here u prime is 3x squared because u equals x cubed. And the bottom is 1 minus x cubed quantity squared. So you can simplify that as 3x squared over 1 minus x to the 6th. All right, at this moment, it's best to practice the content by moving on to the recitation PowerPoint slides. And the first exercise, I listed 3 inverse hyperbolic functions, and we're going to use the first set of rules to find the derivatives of each function one by one. And the next example is all about integrating 3 different kinds of integrals, and I think each of which corresponds to 1 type of formula in the list. Okay, please go ahead and check those videos as well. And in the last practice exercise, we have 2 definite integrals, and each definite integral corresponds to an area between the curve and the x-axis, and I have shown those in the graphs here. So this is the first graph and this is the second graph. If you use your calculator and graph these two functions, and please go ahead and go over all of these exercises. First, try to do those by yourself, and then once you get stuck, just open the video and see how I handle those problems with my own way. All right, this is the end of the whole section video, and thanks for watching. I'll see you in another video. Bye.